Assalamualaikum. In this video presentation, my group members and I will explain about the topic of application of differentiation in the term of related rate. But before we go further, let me introduce myself and also my group members. We are the students from Faculty of Applied Science UiTM Cawangan Perak, Kampus Tapah, A4AS120214. Our first group member is Muhammad Farabi bin Muhammad Amin. The second group member is Muqhri Imran bin Zukri. The third group member is Alisa Diyana binti Amran, and the fourth group member is Syafia Amirah binti Ismail. Okay, now guys, let's take a deep breath and let's enjoy our video presentation.
Hi, Assalamualaikum. My name is Muqhri Imran bin Zukri, and today we're going to learn about the application of differentiation. So, to be more specific, today we're going to learn about a subtopic from the application of differentiation, which is related rates. So, without wasting any time, let's start. In differential calculus, related rates problem involve in finding a rate which a quantity changes by relating that quantities to other quantities whose the rate of change are known. So the differentiation with respect of time requires the application of chain rule, which we have learned before, since most problem in this topic involve several variables. For example, if the function of f are defined as f equal to fx, then the derivative of function f can be related with respect of other variables. These are the example of related rate questions. So, in this topic, to answer related rate questions, these common formula are used to answer the question. If two related quantities are changing over time, then the rate at which the quantities change are related. For now, let's continue to the next part, which is the related rates problem statement.
Hi, Assalamualaikum. My name is Alisa Diyana binti Amran, and in this slide, I will explain about the problem statement and I will explain deeply on how to solve this problem. So the first statement is, a block of ice in the shape of cylinder has a radius of r cm and height of 2r plus 3 cm. So the ice melt at constant rate of 4 cm³ over second. So the first thing that we need to do is to highlight and to identify all the keywords given from this question. Okay, so the first question is to show that the volume of ice is equal to 2 pi r cubed plus 3 pi r squared. And the second question is to know how fast the radius changing at the instant when the radius given is 2 cm. Okay, now we are here to solve the problem from the previous slide. As the first question from the previous slide is to show that the volume of ice in the shape of cylinder is equal to 2 pi r cubed plus 3 pi r squared. So don't be worried too much for this question. We just need to identify well the keyword given from the statement where h is equal to 2r plus 3. And the second important thing that we need to know in order to answer this question is we need to remember well the volume of cylinder's formula, which is pi r squared h. So the first thing that we need to do is to write down this formula into this equation, and then we need to substitute the h here with 2r plus 3. Okay, the last step that we need to do is to expand the value in the bracket with pi r squared. So here is the last answer where we have shown that the volume of ice in the shape of cylinder is 2 pi r cubed plus 3 pi r squared. Okay, now we are here to solve the second problem where we need to identify how fast the radius changing at instant when radius given is 2 cm. So in order to determine the dr over dt, we need to apply the chain rule formula. The reason why we need to apply the chain rule formula is because we need to put the other information, which is dV, into this equation. As a result, we will get the value of dV over dt, which is -4. The negative sign was added into this value is because the ice was melted. It means that the phase of ice was changed from solid to liquid. And now we just need to focus on dr over dV. In order to get the value of dr over dV, we need to change its position, where dV need to be at the top while dr need to be at the bottom. It is because we need to differentiate V with the respect to R. As the first question before, we have got the volume of ice with the shape of cylinder, which is 2 pi r cubed plus 3 pi r squared. So we just need to differentiate this volume and it will become like this. So as the question, it said that the value of R is 2. So we just need to substitute R here with 2. As a result, we will get the answer of 36 pi. But then don't forget, we need to have the value of dr over dv and not dv over dr. So we just need to change the position back, where dr need to be at the top and dv need to be at the bottom. And the answer will be 1 over 36 pi. And then we just need to multiply 1 over 36 pi with -4. And the answer will be -1 over 9 pi. So that's all from me. The next problem statement will be harder and it will be explained by Syafia Amirah.
Hi, my name is Syafia. I would like to present the second problem statement that we're using in our life. Let's see the problem statement. As we know, related rate can be used to our applications of life. This is the problem statement that we use such as a leader. So let's see the question. A second problem statement is a 10-meter leader is leading against a wall. The top of the leader shifts down at the rate of 2 meters per minute. How fast is the angle between the top of the leader and the wall changing when the angle is pi per 4 radian? First, we must take out the information given. So, the question is, how fast is the angle between the top of the leader and the wall in radian? So, we can solve the problem with the trigonometry equation. If you don't understand why we use it, so let's see that cos theta is adjacent per hypotenuse. We simplify the equation that W equals to 10 cos theta. Then, we differentiate the W that equals to -10 sin theta. So, that's only for the rate of the wall. Now, we need to find the rate of the angle by using the dW over dt times with the d delta over dW. Then, we substitute the value inside the equation and information given. dW over dt is equal to -2. And d theta over dw is equal to 1 over -10 sin theta. Then we simplify the equation by multiplying them, then we can get 1 over 5 sin pi over 4. So the answer will be 0.283 radian per minute. So that's all from me for the problem statement 2. Now I will pass to Farabi.
Finally, in conclusion, we can say that the solution to find the answer for both questions are accepted. Those are some ways to solve problem about related rate. The related rate concept actually had been used in our daily life without we realize. For example, we know how much amount of sugar to be added in tea to get the perfect sweet taste. So do not think that is no use to study related rate. Okay, thank you for watching our video. That's all from us. Thank you and bye.